Okay, vertex form of a quadratic function is y equals a times the quantity x minus h plus k. And if you remember from yesterday, the minus h tells you how the graph moves side to side, and the k tells you how the graph moves up or down. So if we had a parabola that looked like this-ish, the vertex would have the coordinates h, k. So where it says vertex, you can write h, k. And I wrote, remember opposite for h, because if it said x minus 2, that would actually move the graph right 2, so your vertex would be at positive 2 comma something. If it was x plus 5, that would mean left 5, so your vertex would be negative 5 comma something. Every parabola has an axis of symmetry, a symmetry line that goes directly through the middle. And my sketch might not be perfectly symmetrical. It's really not symmetrical at all. But a true parabola is symmetrical, and this line is called the axis of symmetry. So you may want to write AOS next to axis of symmetry. We will use that abbreviation in the future. The equation for a vertical line is x equals, because of Vux. So x is going to equal the x value of the vertex. So the x value of the vertex and the axis of symmetry are linked together. The y-intercept is where the graph crosses the y-axis. And this point has the coordinates 0, comma something. So if you're ever asked, what is the y-intercept of this function, you can put 0 in for x and figure out what y equals. That would be the y-intercept. The x-intercepts are where the parabola crosses the x-axis. And you may notice there are two x-intercepts on this graph. There's an x-intercept here and here. So some parabolas have two x-intercepts. Some of them have one. Some of them actually have none. If the parabola was hanging out like up here, it wouldn't ever touch the x-axis. There would be no x-intercepts. Underneath x-intercepts, I would like you to write solutions, roots, and zeros. Those four terms are used interchangeably. The x-intercepts are the solutions of the quadratic function. The x-intercepts are the roots of the quadratic function. The x-intercepts are the zeros of the function. So one kind of confusing thing about quadratic functions is you're going to hear x-intercepts, solutions, roots, zeros. They all mean the same thing. We need to graph each quadratic function and then state the domain and range. So we'll need to talk about the domain and range as we graph these. The first one is the parent function, and you may want to write parent function next to this. It's the most simple quadratic function that we can graph. So for this one, I am going to choose the x values -2, -1, 0, 1, and 2. And this should be pretty easy to plug in. When you square something, you're multiplying the number times itself. So what is -2 squared? -2 times -2 is 4. -1 squared? 1. 0 squared? 0 times 0 is 0. 1 squared? And 2 squared is 4. Plot those 5 points and let's look at what it looks like on the graph. when you draw in your parabola, try to make it a curve, try to make it a U shape, not a V shape. Okay. If you draw your parabola well, and I don't always draw my parabola very well, you should have a fairly symmetrical around the y-axis parabola. This vertex is at 0, 0, and this function has a minimum at 0. The minimum is the y value of the vertex. Basically, of all of the numbers that you could possibly plug into this function, what is the smallest y value that you could get out of the function? Well, if you look at this graph, the lowest point on this function is that vertex, and that vertex has a y value of 0. So the lowest number that you could get in this function is 0. The minimum is tied to the range, so that's why I wanted to point it out to you. Okay, domain. Domain is the absolute easiest thing in all of these graphs. The domain represents the x values. So in case you have forgotten, domain is x values. And the domain is all real numbers. And you can use a capital R with a double stem to represent real numbers. Why is the domain all real numbers? Our function is y equals x squared. Are there any numbers that you can't square? You can square positive numbers, you can square negative numbers, you can square fractions, you can square decimals. There aren't any numbers that you can't plug into this function. So because the domain is the x values, they're asking what numbers can we plug into this function? And the response is everything, anything. The range, however, do you notice anything interesting about all of these y values in our table? They're all above 0. They're all positive. There aren't any negative numbers. And if you look at the graph, the lowest y value is 0, and all of these other y values are larger than 0. So y is greater than or equal to 0. In this next equation, what does the plus 6 indicate inside the parentheses? Shifting left 6. And what does the minus 2 indicate? Okay, do you remember all that from yesterday? Yes? Okay. So, since this graph has been moved left 6 and down 2, the vertex is going to be at -6, -2. So instead of the vertex being at 0, 0, the vertex is going to get shifted left 6 and down 2. So there's our vertex. Next, I'm going to draw in my axis of symmetry. Your axis of symmetry is x equals the x value of your vertex. And it's the vertical line that goes directly through your vertex. The axis of symmetry is helpful in the next few steps, so that's why we draw it in. If I were to choose the x values -2, -1, 0, 1, and 2, those x values would be over here. Think about the shape of this parabola. It's probably going to cut upward, and it won't touch the y-axis until like way, way up off of our graph. So I don't want to plug in those numbers. Instead, I want to pick an x value that's super close to the axis of symmetry. So our axis of symmetry has an x value of -6. Let's choose like -5 or -4. It doesn't matter which of those you choose. I like to go 1 or 2 units away from the axis of symmetry. So step 3, we are going to pick an x close to the axis of symmetry. And I'm going to pick the x value of -4. What do you suppose I need to do with that -4? How do I find the y value that goes with -4? Plug it in. And you can do mental math or grab your calculator and let the calculator do all of the work for you. Parentheses, -4 plus 6, close your parentheses, squared minus 2. Let the calculator do that for you. If you want to do mental math, go for it. Just be careful that you don't make any crazy mistakes. So when I plug -4 into my calculator, I get 2 as my y value. That means the point -4, 2 is on this parabola. So where did that point come from? I picked -4 because -4 is 1 or 2 units away from my symmetry line, and I plugged that into the function to get the corresponding y value. Why do we call the axis of symmetry a symmetry line? Because the parabola is symmetrical. So if this point is chilling on the right side of the symmetry line, what could we do at that point to get another point on the other side? Just reflect it over. So step 4, reflect your point. So this point is 2 units away from the symmetry line. Go 2 units in the other direction. You don't need 5 points to draw in a parabola. You really only need 3 points. You need the vertex, and you need a point on the left and a point on the right. Do we now have the vertex and a point on the left and a point on the right? Absolutely. So draw in your parabola. All right, domain and range. Who's a little bit brave and wants to tell me the domain? All real numbers. Okay, how about the range? Is there somebody super brave who wants to try for the range? No? Nobody's super brave in this class. This class is not super brave. People watching the video now know that you guys aren't super brave. I'm not going to tell them what hour you are, though, so your identity is safe. They can't hear you. All right. Y is greater than or equal to. How did this graph move? It moved left 6, down 2. Well, range is the y values. That's the kind of the up and the down. So if we move down 2, this minimum value is -2. All of our y values are -2 or larger. So the vertex is -6, -2. That -2 is your minimum value. If the vertex is on the bottom, it's a minimum, and your range is y is greater than or equal to the minimum, -2. All right, do you want to try C on your own? Yeah, go for it. First step, find your vertex. This means left 2, down 7, so your vertex is -2, -7. Your axis of symmetry would then be x equals -2. The domain, that's the easy part, all real numbers. How about the range? Okay, and I want you to see that the vertex and the axis of symmetry are linked. The y value of the vertex and the range are also linked together. Now, in D, you don't have to draw this in your notes if you don't want to, but we should at least talk about it. What if the parabola is upside down? What does that mean for the domain and the range? The domain is still all real numbers, but look at the range. This point is not a minimum. This point is now a maximum. So what is the maximum y value on this graph? What's the coordinates of this point? This point is 2, 6. So the maximum y value is 6. So our range is going to have to do something with 6. But are all of the y values bigger than 6 or smaller than 6? Smaller. So y is less than or equal to. If your graph is opening upside down, that switches. Instead of y is greater than or equal to, it'll be y is less than or equal to. When the vertex is at the bottom, it's a minimum. Your range will be y is greater than or equal to the minimum. When your vertex is at the top, you have a maximum, and your range will be y is less than or equal to your maximum.